Example number 2, solving a problem using an exponential regression model. Sonia did an experiment to determine the cooling curve of water. She placed the same volume of hot water in 3 identical cups. She recorded the temperature of the water in each cup as it cooled over time. Her data for 3 trials is given as follows. Okay, so trial 1, trial 2, and trial 3. Compare the scatter plot Compare a scatter plot to display the data. Determine the equations. This should actually be complete. Complete a scatter plot to display the data. Determine the equation of the exponential regression function that models Sonia's data. B part is estimate the temperature of the water 15 minutes after the experiment began, round your answer to the nearest degree, and estimate when the water reached the temperature of 30 degrees Celsius. What I really like about this question is one of them gives you the dependent and it's asked for the independent, and one of them gives you the independent and asks for the dependent. So we can compare the 2 methods, either the value or the intersect. So what I'm going to do now is I'm not going to type in the data, but I'm going to check the data. So I'm going to go stat edit. So I should have 0, 5, 10, 20, 30, 40 3 times because we have 3 different trials. So 0, 5, 10, 20, 30, 40, 0, 5, 10, 20, 30, 40, 0, 5, 10, 20, 30, 40. Get it? So let's check the data here. Just going from the bottom here, going up like this. 25, 33, 44, 61, 68, 78. Good. On to the next row. 23, 32, 44, 59, 66, 75. Good. Next one. Whew! Made a mistake here. Good thing I checked. 26, 34, 45, 61, 69, and 80. Perfect. Now we're all set to find the regression equation. So let's see what this graph looks like. At this point I should see, oh, look at what we have here. We have this equation from the last. Okay, so let's go into my y, and I'm going to just clear that out because that's from my last question. Graph it. Now, I don't see any of my scatter points, or I don't see any of my scatter plots, so let's change our window settings. Our x, which is always in the first column here, is going to go from 0 to 40. So I'm going to say 0 to, let's say 75, okay, because it's well above 40. And then my y min, it doesn't go down to 0, but we'll say 0 to, let's say 100. Let's see how this goes. See what happens here. Ah, look at this. It looks like we have a decreasing exponential function. So just to remind ourselves from the work that we did yesterday, that means that the base will be less than 1 but greater than 0. Okay? So just keep that in the back of your mind so that we can check the regression equation when it comes. All right, so we're going to quit this. We're going to say stat calc, go down to exp reg, and I'm going to go second L1 comma second L2 comma vars y vars, enter, enter, enter. Now our stretch factor is going to be 78, but look at this, our b. It's beautiful. It's 0.97. So that's why we know we have a decreasing function. So when we see this graph, it'll go. So since it is between, since the base is between 0 and 1, this is the shape of our graph. Okay, that is just beautiful. So I'm going to look at my this here again. So I'm not going to say y equals abx, where a, no, that's not what we want to do. We're going to say y equals 78.681. I'm just going to put everything in brackets. Why not? Keeps it nice and contained. And then 0.972, because we round up, to the power of x. Fabulous. This is great. You'll notice that I have 3 decimal places properly rounded. So estimate the temperature of the water 15 minutes after the experiment began. So round to the nearest degree. So we're given time. And let's just look back. Time is our independent. So we are going to use the second trace value. And x equals 15, y equals, so second trace value, x equals 15, y equals 51.007. degrees Celsius. I'm just going to double check for the rounding here. 51.006, but we rounded up to 7. Good. Estimate when, so the time, when the water reached a temperature of 30 degrees Celsius. Round your answer to the nearest minute. So we are given temp. So when we scroll up here, we notice that the temperature is our dependent. So that's our dependent. So we're going to use the intersect method. So we're going to go second, trace, intersect. But first what we need to do is we need to say y2 equals 30. So I'm going to go into my graphing right here. I'm not going to erase this. Okay, my y1 is important still because I need to see where those two intersect. Go 30, we're going to graph it. Woohoo! And we can actually see the intersection point here, so that's really good. So second, trace, I'm going to go down to intersect, enter, first curve yet, second curve yet, guess, okay. So when y equals 30, x equals 33.3676, so 33.368. Let me just double check if I remember that right. 368. Now I'm going to remember that this is going to be minutes. So I'm going to just go back and remind ourselves of the specific rounding instructions. Round your answer to the nearest minute and round your answer to the nearest degree. So I'm not going to put a box around this answer actually. I'm going to say y equals 51 degrees Celsius. This right here is my final answer. And this one, I'm going to erase the box from it too. I'm going to say x equals 33 minutes. And we're done.